All right, so we'll be given information like this. Sometimes they'll use capital letters to mean the angles. A lot of times we will use Greek letters to mean the angles. So another way this could be written is this one might be called alpha as a 30 degree. And C, we usually use a gamma, it looks like this, as our 90 degree. Again, that just means the same thing. So little letters are going to be sides. Capital or Greek letters are going to be angles. So when we're looking at this, we know we have a right triangle here. So I'm going to start by drawing my triangle. We should, for the most part, be working with right triangles, but sometimes they're looking at some weird relationships. So make sure you look at where we want to be. So we're going to start with our right triangle. I know that point C is my 90 degrees, so that's this side. When we're looking at naming the sides of the angle versus, or the sides of a triangle versus the angle of a triangle, side C is going to be opposite our right angle. So side C is going to be across over there. Whichever angle I pick to be angle A, like let's say I call this guy alpha over here, side A is across from it. Excuse me. So if you think about the name of an angle, it's going to hug the side that it's talking about. It's not one arm of it, it's hugging the side it's talking about. So since angle A would be this guy here, it's hugging this side of the triangle. So it's going to hold the edge of the one it's talking about. So side A is across from angle A. So this would be if this was alpha. So just like that, beta or angle B is going to be across from side B. So that's how we can decide which one we call which, because the relationships do matter. And we need to find all 6 pieces here. I'm just going to rename this real quick to be gamma, just so we're really clear which pieces we're talking about. I'm going to use the Greek letters just because they're easy to tell apart. So we know that our angle A, our angle alpha, this guy is 30 degrees. So this guy's 30 degrees. We know that angle C is 90 degrees. So what is our beta going to be, our angle B? 60. This is a 30, 60, 90 triangle. So this is going to be 60 degrees. So now we have all of our angles. That's great. The only side we know, though, is side B. We know that this side has a measurement of 20. So that's this side. So we have a couple of options for how to go through this. After we wait for her to talk again.
It's time for the third period WIDA testing students to head to their testing room. Teachers, please check the third period tab. We had many students in first period that didn't make it to their testing room, so please check that tab. Look for your name, send the students. Thank you.
Y'all check your emails. She wouldn't have to talk so much. I'm gonna double check because we said to. And then I'm gonna grab the door. Actually, Zion, can you grab the door for me real quick? Thanks. Just following my instructions. Pretty sure none of us have it, but we're just double checking. Yeah, we don't. We're good. Hello, my dear. All right. So we have a couple of options when we're trying to figure out the sides. We could notice that this is a 30, 60, 90 triangle, which we know is based off of an equilateral triangle, just cut in half vertically. So we would know that this side and this side have a relationship, our short leg and our hypotenuse. We did that when we were finding our special values for our unit circle. So that is one way you could approach it, is that our 30, 60, 90s are always based off of a right triangle. That does require us sometimes to be drawn to scale, because this is actually my 30-degree angle, so we have a short side here. Our other option is to go, wait a minute, I know what this angle is. I know my beta, and I know what side B is. So we could use one of our trig functions to get there. I know the opposite of this angle, and we want to find either our hypotenuse or our adjacent. So if I know my opposite side, and I want to find my hypotenuse, we can use our sine, opposite, and our hypotenuse. Because we know that the sine of 60 degrees should be the same thing as our opposite, that 20 over our hypotenuse, C. You could also use tangent to do this one because that would give us our opposite over adjacent. That's totally fine as well. It would just be a different leg. So we want to know what C is on this case. How can I solve for C? I see two options for what to do. How do I get C by itself? As I said, we can divide by 20. Totally fine. As I heard, multiply by 1 over 20. That's going to give me sine of 60 degrees divided by 20 equals 1 over C. How do I get C by itself? I don't want 1 over C, I want C. Yeah, you could flip both of them. I was like, we could also, at this point, we could multiply by C and then divide by the sine. That's totally fine. But we're going to wind up with 20 divided by the sine of 60 degrees should be our C. And what we can do is we can put that in a calculator. So let me get my calculator open. It's going to give us the blank version. Come on. There we go. Exit. Calculator. It's going to take a second. And probably open on the wrong screen. Because of course it is. Because my computer loves me so much. Oh, naturally. Okay, so we could absolutely type this in the calculator where we have our fraction. We need to make sure we're in degree mode. I'm in radian mode. We have a question in degrees. So first thing I got to do is switch us back into degrees. And then I'm going to quit. So we need to have degree mode since we have degrees in our sine. We're going to do our 20 over sine of 60 degrees. And it gives us a kind of gross number. It's even rationalized for us, though. So we get 40 square root of 3 over 3. So the length of side C is 40 square root of 3 over 3, which is technically a very lovely answer. It is fine. It is rationalized. It is things like that. It's not super helpful if we were trying to actually measure a triangle. But this is a totally correct, absolutely viable answer. If we want to know what that is actually decimal-wise, on the yellow calculators, just above the enter key is the 2 arrows. That switches it back and forth between decimal mode. So if you ever need like a decimal answer, which we will later on, that would be where we find it. So it's about 23.09. But we're going to leave it as the fractiony grossness. So now I know a leg, and I know my hypotenuse. How can I find my other side? Pythagorean theorem. Same vibe. So we can use our trig functions to help us find the pieces even if we're missing stuff. So let's do our Pythagorean theorem to find the third one because I didn't want to have to do that too many times because it's gross. So we know we're going to have our a squared, side A, which is one we don't know yet, plus our b squared. We do know b. B is 20. And we want to know when that equals our c squared, which is that 40 square root of 3 over 3 gross squared. One of the beautiful things about this calculator, if I switch it back, we can come through and we can just square it right there and get our answer like that's 533 1/3. So we don't necessarily have to do all that math ourselves. So we're going to have 533 and 1/3, which is also going to be, to get that as a fraction, I'm going to go here. I'm going to hit those 2 arrows. 1,600 over 3. There we go. Just because that's easier to deal with. 1,600 over 3. You could also take our 40 square root of 3 and square that, put it over 9, and simplify there. There's a lot of processes through. So we're going to have our a squared plus 20 squared. Well, that's 400. Equals this. What do we do next? So yeah, we're going to subtract. So we're going to have our a squared. We're going to take our 1,600 over 3. Ew, but it's fine. And we want to subtract 400. So we've got our 1,600 over 3, and we're going to subtract 400. And we get 400 over 3. Gross. It's about 133. So our a squared equals 400 over 3. So what does a equal? What's our side a's length going to be? Square root of 400 over 3. Square root 400 over 3. Well, that gives us square root of 400, that's 20, over square root of 3, which we need to rationalize. So we're going to have 20 square root of 3 over 3. I have my length for side A, and I have my angle for side A. I have my angle B, and I have my side B. I have my angle C, and I have my side C. So we need to make sure we have all 6 pieces to be able to have solved the triangle. All 3 sides, all 3 angles. Yes, including the right triangle, the right angle. We're going to practice this a couple more times before we do anything weirder. Okay? So here we go. We've got side C is 30. Angle B is 45 degrees, and angle C is 90 degrees. So again, I'm going to start with trying to draw my triangle, just because it really helps to be able to look at it. So we know we have a right triangle here because we've got our angle C at 90 degrees. So this guy's C, which means this is side C over here. We will almost always have side C be the hypotenuse. I cannot think of a time when we don't because it's just wrong. But as far as which other point is A and which one's B, it genuinely does not matter. So I know that if this is point B, then this is angle B, and it's 45 degrees. Angle C, we've got our 90 degrees. This is going to be our side B, which means this guy over here, that's angle A, and this is side A, which we know nothing about. We do know that our side C is 30 degrees. So start out, or 30, whatever units it is, feet, inches, centimeters, miles, whatever. What is the first thing that we can figure out here?
The other angle.
The other angle, angle A,
45.
is 45 degrees. So angle A, which you can either use the capital or we can use the Greek, is going to be that 45 degrees. So that means we know what about this triangle? It's a 45, 45, 90, which means it's also an isosceles triangle. Our 2 legs are going to be the exact same. If they have that same angle, they're going to have that same length. So we know that our side A is going to be the exact same as our side B, because those angles are the same. Just writing it down because I don't think that's right, but it gets the vibe. Isosceles, because it's isosceles. So we know those two sides are the same. So we could use a trig function to find out what the length of that side is if we want to. Because we know something about, for either of these angles, I know an angle and I know the hypotenuse. I could use one like that. It's kind of the hard way on this though. Because I know C and I know these two things are the same. So I could do this as like, call this side x and call this side x. I could do this one with just the Pythagorean theorem because I know my A and my B are the same. So I could put this as A and B, I both call x, just to be able to figure it out, and because we're more used to that. Because this is going to be x squared, there's my A squared, plus my B squared, which I'm going to also call x, equals my C squared. Well, we can simplify this a little bit. X squared plus x squared gives me 2x squared, and 30 squared gives me 900. What's our x squared? What does x squared mean? 450, because we divide both sides by 2. So what's the value of x? Square root of 450. Simplify it. 15 square root of 2. So since it's an isosceles triangle, we can have kind of a cheat code. We know those two sides are going to be the same, so we don't have to necessarily use the trig functions to get there. I know that the side A is going to be 15 square root of 2. I know side B is going to be 15 square root of 2, and side C we knew was 30. So I've got my three sides here. So these are the sides. Oh, that's not fun. So these are our sides. And then we have our angles, which are these guys. Those are the first pieces we figured out. So we've got all three sides, we've got all three angles, we have solved this triangle. So we will be given enough information to do it, but sometimes we just have to look at our pieces in a little bit different way. Is that probably the next one? Okay. Last one in this kind of context. And then we'll go look at some other weird things. So we're asked to solve a triangle given side A is 5, side B is 5, and angle C is 90 degrees. So I'm going to draw my triangle, label the things we know. So if I draw a right triangle, because we get our C that's 90, so that means this guy is point C, which I'm going to make B purple, because we know that our C is 90 degrees. It does not matter which angle I make point A and which one I make point B. So I'll call this guy A, which means this is side A, so it's 5. Which makes this point B, and side B also has a length of 5. What do we know from this? Yeah, our angles are equal. Because they have the same side, that means they have to have the same angle. They have that same length. So these two pieces have to be the same, which means what are going to be the measures of angle A, or alpha? 45 degrees. So alpha is 45 degrees. That would be the angle for side A. Our beta, our angle for side B, is going to be what? 45 degrees. Because we know it's isosceles. So the only piece we have left to do is the hypotenuse. We got to figure that out. How are we going to find our hypotenuse? Pythagorean theorem. Where we take our side A, which is 5, squared plus our side B, which is 5 squared. And we want to know when that equals our C squared. A squared plus B squared equals C squared. So we know 5 squared is going to be 25. And we know 5 squared, which is going to be 25. 25 plus 25 gives us 50. So what is C going to be? 5 squared or 2? So sometimes we can use our trig functions to get where we need to be. Sometimes we can use our logic and reasoning to get where we want to be. And sometimes we'll use Pythagorean theorem to get where we want to be. So our side C, that's our 5 root 2. So we have our 1, 2, 3 angles. And we have our 1, 2, 3 sides. So we have all 6 pieces we need here. So when we just give it to you as a triangle, it makes things all super lovely and nice and organized and easy peasy. We are not always going to give things to you as triangles. I have yet another poster that's falling. Good gravy. These things are falling off like crazy. So a lot of times in 6-7, and what a lot of 6-7's homework is actually going to be word problems, stories. So I grabbed the wrong pile of questions. So I'm going to give them to you, but I have the wrong ones in my hand. So there we go. I printed them for you, so you don't have to try and rush and write the paragraphs down. I have all the paragraphs that we're doing today, just because some of these are wordy. So I have them, so you don't have to write them. You can if you want to, that's yours. But I don't like that to be rushing to a paragraph. And the paragraph is not the hard part. So with these, as with a lot of story problems, when they're describing something, it's really handy to draw it. And you guys get to see some of my beautiful art skills today. I'm so good at art, like sarcasm. There is zero judgment ever on your drawings because I'm so good at drawing. So what we have is we have a pilot flying at an altitude of 5,000 feet. So I know we live on ground, so here's our ground. Here's the grass, la la la. And we have an airplane. Ooh, airplane. Ooh, I'm so good at art. It's beautiful. It's an airplane that is flying along at 5,000 feet. Zero judgment on your art skills ever. It's beautiful. So 5,000 feet. Bless you. Altitude is measured at like a right angle from the ground, so we can think of that being a right angle here. So that's what we get from that first sentence. We have a pilot flying at 5,000 feet and is approaching a runway at 10 degrees. So he's looking ahead at where he's flying. And the runway where he wants to land over here, he is at 10 degrees. So what we're trying to figure out is we want to know what distance he needs here in order to be able to start descending down, because he's got like one of those scanners where you can tell his distance from the airport, but it's doing a straight shot. So he needs to know how far from the airport he needs to start lowering his altitude. So we're looking here, and we want to know about this distance. What we have is we have an angle. We have the side opposite that angle. And we want to know about the hypotenuse, right? So which of our trig functions talks about an opposite and a hypotenuse? Sine. So what we're going to do is we're going to use that. So we're going to use that sine of 10 degrees we know is going to equal our opposite over our hypotenuse, right? So our opposite is our 5,000. Our hypotenuse is that distance, that x that we're trying to find. So it's very much like that very first one that I showed you, where we want to figure out what x is to get there. So the first thing I'm going to do is we can absolutely go in the same exact order we did for the first one we did today, but I kind of don't like to wind up with where you have to flip to make the reciprocal. So I'm going to multiply both sides by x to get x out of my denominator, so that I have x times sine of 10 degrees equals 5,000 feet, but we don't necessarily need to put the units in right now. And then to get my x by itself, I'm going to divide both sides by that sine of 10 degrees. Because sine of 10 degrees is a number. It's a gross number, but it's just a number. So we're going to get that our x is going to be the same thing as 5,000 divided by the sine of 10 degrees, which we can type into the calculator. So we're going to do our fraction that we do 5,000, missed a zero, over the sine of 10 degrees. It is very, very important that we make sure we're in degree mode. It makes a difference. And what we get is 28,793.9. Let's just take one decimal place on this one. 28,793.9. $28,973.9 feet. Make sure we include the units. Since these are stories, we usually have them in here. So we know if we're flying at 5,000 degrees, he needs to be 28,000 feet away when he starts his descent. And they have like radars and sensors and stuff that tell them how far they are from the nearest airport in the cockpit, so they can know that. They need this distance. Okay? So we don't need to solve the whole triangle. We don't need to figure out how far the plane is from the airport. We don't need to figure out what angle he's at towards the ground or towards the airport. We're just looking for the piece we're being asked for here. Okay? Questions on this one? Okay. Here's the next one. We've got to find the distance between 2 points, P and Q, on the opposite shores of a lake. They use a separate point, a reference point. That's 50.5 meters from P, so that RP is perpendicular to PQ. So we've got too many letters here. It's really tough to think about. What we have is we have a lake. Ooh, beautiful lake. I'm so good at art. And we're looking at points P and points Q that are on like the far side of the lake. Like we've got some information. Actually, I'm gonna put Q like straight over from P. I'm not gonna, my iPad's freezing out on me. I'm gonna put Q kind of like right up here, so we're kind of close to it. So it's still like crossing the lake where I can't quite like run a measuring tape to it. And then our other thing that they're giving us is they're saying, well, since we can't figure that out, I'm going to look at point R, which I know that RP, this side, is going to be perpendicular to PQ, like this. And we know that angle PRQ, so this angle over here is this 72 degrees and 40 minutes. And we know that the distance from R to P is 50.5 meters. So sometimes we just have to stop and sit and look at our things here and see what is it that we know. I know this angle, because like this lake is actually inconsequential. I know this angle is 72 degrees and 40 minutes. And I know this side, this leg, and what we're looking to find is the distance between P and Q. Find distance D. D is between P and Q. This is the guy we want. So label the things we have, figure out what the heck it is we're looking for, and then see where we can go from there. I have an angle, I have the side opposite to it, and I have the side adjacent to it. What can we do with our opposite side and our adjacent side?
Cosine.
Tangent. Cosine requires us to know something about our hypotenuse. We could do that and then figure out the other side, but since this is my right angle here, what we have is our opposite and our adjacent, not the hypotenuse. So we can take and put this as tangent of that angle, our 72 degrees, 40 minutes, is going to be the same thing as our opposite, that side D, over our adjacent, 50.5. Can we type 72 degrees, 40 minutes into the calculator?
No.
So what are we going to need to do?
Multiply the 40, or divide the 40 by 6.
Divide the 40 by 6. So we need to get this down into be just degrees. So we're going to need to take our degrees in minutes and simplify this down into be just degrees. So we know we have our 72 degrees, and you're exactly right, Zion. We're going to take our 40 minutes and divide it by the fact that there's 60 minutes per degree. So we're going to get 72 2/3, which is all well and good, but annoying as heck to type in the calculator. So let's make this be an improper fraction. What is 72 2/3 as an improper fraction?
218.
We should get 218 thirds. So we could rewrite this as our tangent of 218 thirds equals that distance over 50.5. We can work with 50.5, that's fine. What are we going to do to get the variable D, that distance by itself? I'm going to scooch this up just a smidge so I have a little bit of space. So multiply both sides by that 50.5. So we're going to have our 50.5 times tangent of our 218 over 3 degrees gives us this distance. So what are we going to get as our distance here?
Mm-hmm.
161.8 meters. Because our original unit was in meters. Okay? Let's do the next one. I don't know that we're gonna get through the last two, but I want to do the next one for sure. So we're approximating an angle of the sun if a person is 5 feet tall and casts a shadow that's 4 feet long. So we have a person. Person. They're casting a shadow on the ground. So we know that they are 5 feet tall and their shadow is 4 feet long. We want to know that angle, the angle the sun is making, because the sun comes from up over here. I don't know why we have a pink sun, but we have a pink sun. So we want to know that angle. We can assume that this person is standing straight up and down. Again, I have the height and I have the other leg. So I have an opposite and I have an adjacent. So we don't have a name for this angle, so I'm going to call it alpha. What we know is the opposite and the adjacent. Opposite and adjacent is which trig function? Tangent. So I know that if I knew that angle, we'd have that the tangent of alpha is going to be our opposite, which is the 5, over our adjacent of 4, right? We want to try and figure out our alpha here. So what we're trying to do is we're going to try and untangent it. I would like it to be not tangented. I just want to know the angle. So what we're going to do is we're going to take the inverse. We talked about this very briefly, like I think in section 6.2, but then we did all the graphing, so our brain turned into goo. So we're going to take the inverse tangent of both sides, which means that's going to get rid of our tangent over here. And we're going to do tangent inverse of 5/4. So this is the inverse. To get it to move to the other side. To get the angle by itself, we're going to take the inverse of it. So what we do to do that on the calculator, because that's really the only option, on our trig function buttons, above them we have the little inverses. We only have for sine, cosine, and tangent. So if you get any other trig functions, you don't have to pay attention to that. But what we're going to do is we're going to hit the green button at the top. I'm going to need my finger. There we go. Green button. Then we're going to hit tangent. It even puts the little -1 in there to remind us. This is our inverse tangent. And we're doing our 5/4. We're in degree mode right now. So it's going to spit out a degree for us. So we're looking at 51.34 degrees. If we wanted it in radians, all we'd need to do is switch it into radian mode. Yes, dear?
So what would you do if it was like cosecant, secant?
If we had cosecant, we would need to know that that was the reciprocal of sine. So we would take 1/sine of whatever our angle is. I was going to say, with these, for the most part, in stories, we should not wind up with secant, cosecant, just because that's going to make life really hard. But it would be the same thing. We just have to know those reciprocal relationships ourselves. So 51.34 degrees would be what we have. So this angle, our alpha, would be our 51.34 degrees. Sometimes in the text, they will ask you to put it as degree, minute, seconds, which we've done. Sometimes you can leave it as decimals, so just make sure you're reading your instructions. Okay? We're going to keep working with these stories, checking out these inverses and looking at it. We've got a couple more pieces to look at in section 6-7, but that's kind of the vibe for 6-7. That's the last section of this chapter. Okay? We are going to do, we've got quiz 3 tomorrow. That date is wrong. That says Tuesday, and Tuesday's today. We're looking at tomorrow, which is February 5th. Quiz 3 tomorrow. If you need a copy of the review, I've got them over in the hanging folder. February 5th, which is a Wednesday. So here's the number for the question numbers for 6-7. I do have the digital version of the text posted. Our unit exam is going to be on the Monday, which is, I believe, not the 9th, but the 10th. 9th was a Sunday. There we go. I'm 90% sure on that exam. Yeah, on the 10th, which is a Monday. Okay, so we've moved it from Friday up to the Monday. Just so we have a little bit of extra time. Okay, so you guys have like 2 minutes left.
You said there is a review.
Yes, if you need a copy, the review for quiz 3 I've got right here. If you need homeworks 6.5 or 6.6, they're in this very bottom folder here. If you ever need a copy of Unit Circle, that's what's in the middle here.